What's up guys, and welcome to this video on question 9 of the IEB AP Maths exam from 2018. Okay, so question 9 is all about integration. And this is usually a section that most people hate, but it's really not too bad, and I hope this video will help show that. Okay, so question 9 is what we want to go over, and we have 9.1a as a proof. Okay, so we want to prove that sine cubed theta is equal to sine theta minus sine theta cos squared theta. So let's start off by saying the left hand side is equal to sine cubed theta, and the right hand side is equal to sine theta minus sine theta cos squared theta. So I'm going to work with the right hand side. So I'm going to pull out a sine theta. So I'm left with 1 minus cos squared theta. And from my trig identities, I know that sine squared theta plus cos squared theta equals 1. So 1 or sine squared theta equals 1 minus cos squared theta, and that's exactly what I wanted. So I can say this is equal to sine theta and replace 1 minus cos squared theta with sine squared theta, which is equal to sine cubed theta. So my right hand side is equal to my left hand side, so we have proven the statement. Okay, so we can move on with the second part of the question, which as per usual is to integrate what we've just worked with. So we want to find the integral of sine cubed theta, and we already proved that that is equal to the integral of sine theta minus sine theta cos squared theta. Okay, d theta, putting brackets around. Okay, and now what we want to do is we can put the integral for each part individually across the minus sign. Okay, so now we can work. Okay, so the integral of sine theta is minus cos theta. Okay, and then we have minus. Okay, and here we have a product rule coming in. Okay, and basically we know that the derivative of cos is sine, right? So we've got to work with that. Or the derivative of cos is minus sine. So we've got to work with that fact. Okay, so basically we know that the derivative of cos theta is equal to minus sine theta, right? So if we instead of cos theta, what if we had cos cubed theta? So the derivative of that is going to be equal to 3, and then I'm going to write this like this, cos theta squared. Okay, and the reason why I write that is to show now we have the product rule happening. So now I have to differentiate the inside, which is equal to minus sine theta. Derivative of cos is minus sine. Okay, so basically what I have now is I am going to pull this minus sign to the front, and what I have is cos squared theta sine theta, which is exactly what this is here. Cos squared theta sine squared theta. Sorry, cos squared theta sine theta. Okay, so I need to get rid of this minus 3. So what I'm going to do is I'm going to divide this side by minus 3. Okay, so now I can replace this integral with what I've done here, with the derivative, right? So I'm going to replace it with minus cos cubed theta over 3. Okay, then I'm going to add a plus c at the end because there's no integrating boundaries. So then I'm left with minus cos theta plus cos cubed theta over 3 plus c as my final answer. Okay, then I think I'm going to need a bit more space for the last question. Okay, so we've proven that, and we get ourselves 8 marks, quite generous. Okay, so question 9.2 says I have to integrate x over the square root of 2 plus x dx. Okay, so again, a very interesting question here. Sorry about that. But basically, when we see questions like this with square roots and whatever, the first thing that you want to really think about is to try and use a substitution, specifically a u substitution. Okay, so let's go ahead and substitute this bottom, 2 plus x. So what we want to do is let u equal 2 plus x. Okay, and that means that u minus 2 is equal to x. Alright, so now let's also just differentiate this equation. So du over dx is equal to 1, so du is equal to dx. So basically wherever I see du, I can replace it with dx. So my integral now in terms of u. Okay, so instead of x, I'm left with u minus 2 over the square root of u. Okay, and where I see dx, I can replace it with du. Okay, so that makes life much easier because we can now separate this. So this is the integral of u over the square root of u minus 2 over the square root of u, all of that in terms of du. So I can simplify this a bit, so that's u to the half minus okay, let's just do that, du minus the integral of 2u to the minus a half du. Okay, and those two separate integrals are actually much easier than the original integral. So what I'm left with is I can say this is equal to u to the 3 over 2 times, so I have to multiply by the inverse of that, so I have to multiply by 2 over 3 minus, let's put a bracket in there, minus 2 u to the half, okay, and I need to multiply by the inverse of that again, so times 2, and a quick test would be to differentiate this. The differentiation of that is equal to u to the minus half, which is what I want. Okay, and then I'm going to add a plus c at the end of that. Okay, so now I have done everything there, so now I can just start substituting values back. So instead of u, I'm going to put in 2 plus x to the 3 over 2 minus, and I'm going to say that's 4 2 plus x to the half plus c. Okay, and that would be my final answer. Yeah, so that's the answer to that question. Okay, so cool stuff, guys. Some people, or sometimes you guys want to know how you spot these u substitutions. Okay, it really comes with practice. Once you guys get used to u substitution and use it in a couple of examples, you eventually start to identify when to use these u substitutions. So yeah, so that's the integration question, and you get 8 marks for that. So yeah, thanks for watching, guys, and I hope you found this useful.